Hello everyone, welcome to the arrivabene.com channel. If you are not subscribed already, please subscribe now. Also give us a thumbs up if you like the video. In this video, we'll do a hands-on where we'll create our first Docker container and run it locally. After that, we'll upload and run it on the AWS cloud. We will use VirtualBox, Ubuntu, Docker, and Python locally. At AWS, we use the Amazon Elastic Container Registry, the Amazon ECR, the Amazon Elastic Container Service, the Amazon ECS, and AWS Fargate. So let's stop talking about it and start doing. For this hands-on, we'll use Oracle's VirtualBox. If you don't have it installed, go to this link and download and install it. Open the VirtualBox and click to create a new virtual machine. Define a folder to save it, give it a name, select Linux as type and Ubuntu 64 version as version. And then increase the memory to 2048 megabytes, then click Create. Increase the size of the hard disk to 20 gigabytes, then click Create again. Now, open the setting of the created virtual machine. Under the General setting, go to Advanced tab, define both Shared Clipboard and Drag and Drop to bidirectional. Then, go to the Storage settings and select the Ubuntu's installation ISO to be mounted as the optical drive. If you don't have the file, just go to this link and download it. Go to the system setting, increase the number of the processors to 2 and then click OK. Now we are ready to start our virtual machine. We are going to use Ubuntu as the OS to run Docker, so let's install it. Select Try or Install Ubuntu and then hit Enter. Select the language you want to install and then click on Install Ubuntu. Select the desired keyboard layout and then click on Continue. Select the minimum installation and then click on Continue. Click on Install Now. Click on Continue to confirm the default disk partition scheme. Now select your time zone, then click on Continue. Type your name, give the computer a name, define the username and password. For the sake of simplicity here, select to automatically log in on startup and then click on Continue. Click on Restart Now and then hit Enter to continue. You can skip the Connect Online Accounts step, skip the Live Patch step. I'll choose to not send system info. Click Next. We don't need location service for this hands-on. Click Next. We can complete without install any additional software. Let's make the screen bigger and easier to work on. Just right-click on the wallpaper, then Display Settings. Select the resolutions that best fits your device, then Apply. And keep the changes if everything works well. Let's install the Docker engine and make our virtual machine ready to run containers. So let's open the terminal Let's update the apt package index. This command must run with elevated privileges, so the password must be provided. Now let's install some packages to allow apt to use repositories over HTTPS. Just confirm. Now let's add Docker's official GPG key. So we'll create the key rings folder if it doesn't exist, and then we will download this key inside that folder. Now we can add Docker's repository to apt. Let's update apt package index again. Now we are able to finally install the latest version of Docker engine. Let's configure to not have to use sudo every time we run Docker commands. First, we'll create a group called Docker. And then we'll add our own user to this group. Now we can force the group to be applied right now without the need to log back. And finally, we can run a hello world container to check if our Docker engine is working properly. Analyzing the log, we can check that the image wasn't available locally, and then it was downloaded. So we can also check that there is a message printed by the container. That means our Docker engine is working properly. Before creating an image that will serve to run a container, we need to know which image we are going to start with. For that, we'll look at Python's official Docker Hub repository. Speaking about Python Docker images, we'll find some different kinds of images. For example, we'll have the full image that uses the most recently Debian Linux release. This is probably the biggest image, but on the other hand, it is the safest to use if you are unsure about the requirements we'll need. The name will be Python, the version. If the version is omitted, the tag latest will be assumed. We have Alpine images that are based on Alpine Linux project that was built specifically to run in containers. These images have the smallest size, but they don't have many OS features, what might be an issue for many projects. The tag for these images is Alpine. We also have this link that pairs with the full image but only has the minimal package to run Python, so it's smaller than the full image. We have other tags related to the Debian releases, and also Bullseye, that stands for non-stable future versions of the image. I almost forgot the Windows Server Core that can run containers on Windows. The most important here is to understand well the naming convention of the official images for the platform you decide to work. Let's download some images and compare the size. First, let's download the latest version of the Python's full image. Now let's download the Alpine version. And now the slim version of the image. Now we can list the images and compare the sizes. As you can see, each image has a different size, so it's really important to understand what's the image you need for your project. Now we can create our first Docker image to run a container with a Python program inside. First, let's install the Flask library that we'll use to handle HTTP requests in Python. Now, let's create a requirements file to hold the list of Flask and its dependencies. To leave the nano editor, press Ctrl+X, Y to confirm, and then hit enter. Let's create the main py file to hold our Python codes. It is just a simple Flask program to handle all HTTP requests and return the message return to Python. Save the file and leave the editor. Now we can run the program to test. If we open the listening address on a web browser, we can check that the message is being returned, so our program is running properly. Let's create a similar program to make it a Docker image to run as a container. Create a new folder for this project. Let's create the same requirements file. Save and leave the editor. Let's create the same Python program. The only difference here will be the return message. Save it and close the program. As we want to create a Docker image, we must have a descriptor file to tell the Docker engine how to build it. This is the function of the Dockerfile. So, let's create one. The engine will create a container from a given base image and then run all the commands. Some of them triggers commits that will generate other containers on top of the previous one and create an image of the final container. In the first instruction, we define the base image we will use to build on top of. The label instructions add a metadata key value pair to the image. In this case, we are creating a description to help us to identify this image later. Workdir sets the working directory inside the container. The first copy instruction is copying the requirements file from the host computer to the container. The run instruction is executing the pip command to install the requirements found in the list inside the requirements file. The next copy is copying everything from the Docker's files folder on the host computer to the working directory inside the container. The last one, the CMD, is telling the engine what to run when the container runs, and startup commands. Don't forget to save and leave the editor. Now we need to run the command to build our image. We can check that the image was created by the messages, and then we are able to start our first container. We are passing as parameter to the Docker run command the -d, that means we want this container to run in background, -p that's publishing the port 5000 inside the container in the roast. The name, that we are just giving a name to the container, and then at last we are telling the Docker engine what image to use. Now our container is running, and then we can check on a web browser if it's returning our message. Let's update the address. If you are following me, congratulations, you have your first Docker container running. Now that we have our container up and running locally, let's run it on the AWS cloud. For this hands-on, we'll use the AWS service, Amazon ECR, which is similar to the Docker Hub, an image repository, Amazon ECS, that is a container service, AWS Fargate, that is a container service, serverless, which means that we don't have to manage the infrastructure. For this hands-on, you need an AWS account. Follow the link in this screen to create one. But attention, accounts created within 24 hours might not yet have access to the services required for this hands-on. In this case, you need to wait till you complete at least 24 hours. Another attention point, this hands-on generates costs on your AWS account. If you follow these steps, especially the cleanup at the end, you will probably have less than $1 of costs. So let's start. In the next step, we will install AWS CLI, that is a command line interface to access AWS service. To use it, you have to obtain a programmatic access key. To do so, just follow the link in this screen and then you can get it. First, we will download the installer. Then we need to unzip the file. Then we can install it. As soon as it's installed, we can start the configuration. We have to inform the programmatic access key ID and then the secret access key. Remember, it's a password. If it's revealed, you need to deactivate and then create a new one. Now it's time to upload our Docker image to the Amazon ECR. To do so, we'll need our AWS account ID. To obtain it, one of the ways is just running this command. You can find your AWS account ID in this field. We need to ask AWS ECR for a password and then send this password to the Docker utility to log in the repository. Don't forget to replace the command with your AWS account ID. Now we need to create a repository to hold the image we are going to upload. In this command, we are calling this as my first repository. Now we need to tag the local image and then Docker will know where to send it. Now let's run the docker push command to upload our image to the AWS ECR. Let's check our uploaded image. You can go to the ECR server through the search bar and then repositories. Then we can see our brand new created repository, my first repository. If you click, we can see the latest version of our image is there. Now let's create our container on AWS. Navigate to the ECS service. Make sure you are not running on the new ECS experience because this hands-on is based on the old version of the interface. Navigate to the repositories. Let's check our image and then we can copy the URI of the image. Let's get back to the ECS. Now we can go and just click on Get Started. We'll choose a custom image. Let's configure it. We can give it a name, my container in this case, and then we can just paste the URI we copied from the last step. Now we can tell we want to expose the port 5000, then click on Update. Next. Now just confirm, let's select the application load balancer and next. Now give a clustering name and click next. Now just confirm and click create. Now we have to wait till it be created. Click on View Service to navigate to the brand new created service. And then we can check everything is okay. And let's just click on the target group name to navigate to the Elastic Load Balance where we can find our URL to access this service. On the left side pane, find and click on the load balancers. Then copy the DNS name. This is the URL we are going to use to access our service inside the container. Let's open the browser. And we can check by the message that our container is running on the cloud. Congratulations! Now we reach the end of our hands-on, but we still have such an important activity that is the cleanup activity. Please don't skip this step, or otherwise you might incur in unexpected costs in your AWS account. Navigate to the ECS service. Then scroll down and click on your cluster. Then delete cluster. You have to confirm, type in the message, the phrase they asked you, and then you just have to wait till it's completed. As soon as the cluster is deleted, we must deregister the task. It might not incur any cost, but it's good to clear as well. Then let's go to the repositories under the Amazon ECR. We have to delete our entire repository. Just have to confirm again and delete. Okay, you're good to go. We have created a local container and then uploaded to AWS and have it running there. So if you liked this video, don't forget to give us a thumbs up, and if you like the channel, please subscribe. Thank you so much for watching.